Hello, it's Francesco Ganora here. I would like to show you how to programmatically stop and start a mule flow. I prepared already an example. I created this mule project called flow start stop. Currently contains a mule configuration file with a really simple asynchronous flow. It's based on GMS ActiveMQ. This is the flow is called test flow, and this is the one that we're gonna stop and start. So this just to review quickly how this flow is built. It's really simple. The flow receives a message from a JMS queue called test.flow start stop um, on an ActiveMQ JMS broker. We can look at the configuration as a standard one with a TCP localhost port 61616. I've already obviously ActiveMQ running on my computer. I have here the ActiveMQ console. I've created a test flow start stop queue. I can send messages on this queue. And going back to this flow is gonna just use a logger to log the payload, which is the message I'm sending to this flow. So let's test this out before proceeding with the logic for starting and stopping. So I run this, starting, and then I'm gonna send the test message on the queue just to make sure it works. Uh, of course, I have added to the class path of this project the ActiveMQ jar, which you can see here. It has been added as an external jar to the application. Going to this ActiveMQ console, I can send a message called containing test1 on this the JMS destination. Hit send, and I see that we can see in the console that the logger actually logged the message that I sent. So this trivial flow works, and we can see how now we can programmatically stop and start it. So to do that, I would create in the same application a different configuration file. So I do go new mule configuration file. Let's call it flow control. And then I'm gonna stop the project for now. Then what we would like to do is to control stop and start the flow via an HTTP request. So if I go to an HTTP client such as Postman, what we'd like to do is to do something like this. So to issue an HTTP request to an URL URI called flow control with two parameters, the name of the flow and the action, which can be stop or start. So so now we just build a flow with HTTP request, HTTP listener. This flow it's gonna use a get request. It's gonna use the standard HTTP configuration on port 8081 as in most tests. The path I'm gonna set it to flow control. So then I'd like to assign the two query parameters a name and an action to two variables, so it's easier. They're accessed in an easier way. To assign two variables, well, I can use a two set variable, two variable transformers, but then I will have to use two, so to make things quicker, I'm gonna use an expression component, mel expression component. With this mel expression component, I can quickly assign these two variables. So I've gone flow vars, then, sorry, first variable will be called flow name. And then I go to access the query parameters. I choose message dot inbound properties dot HTTP query params, and then the name of the query param I want to use, which is a name for the name of the flow to stop and start. And I do the same for the action parameters. I just copy and I call this action. And I call the flow variable action as well. So yeah, to keep it a bit simpler, I will call the flow variable name instead of flow name. So the flow variables have the same name as the query parameter. Then I would like to use a choice router, so to distinguish the stop and start action. So this choice router will be invoke something to stop and start the flow based on the action variable. To stop and start the flow, we're going to use two Groovy components that can invoke MuleSoft API. So let's insert the Groovy. Let's insert a Groovy component here, and let's make this a stop action. And the let's to keep things a bit simpler, we can use the default route as the start action. So we're gonna look before we look at the code to stop and start. We have to define the choice conditions. So with mel, so we're gonna have the stop action when flow variable action equals stop. And of course the default will be the otherwise clause without any condition. Let's save this, and then we go to the code, the Java code invoked from a Groovy script that's gonna stop this flow. We look up the flow from the Mule registry. So to access the Mule registry, we start with the Mule from the Mule context. Mule context, then they'll have a registry reference. And from the registry, we can look up the flow with a method lookup flow construct. construct. Yeah. And here we can specify the name of the flow. So flow variable, flow vars, and with name of the flow. This will look up from the Mule registry the flow whose name we specified in the query parameter, and this will be an instance of an abstract flow construct on which implements different interfaces. So that include a stop and start method. So on this object we should be able to invoke the stop method. Do the same for the start. Let's just check the code. It looks okay. So for the start we do the same, but we use the start method. So let's save this, and let's remember that in our test the flow we're gonna stop and start is called the test flow, which is in the same namespace because all the flows, the objects in regardless of the XML configuration file, the Mule configuration file they're contained in, all the objects in the same Mule application belong to the same namespace in the saying they're within the registry. So let's run. Well, hopefully it will work right away, otherwise we'll debug it. So the takes a little bit time to start up. Hopefully it will start up. So let's stop and start again. Yeah. It's deployed, now it's started up. Let's check the main flow still works. Let's send to the same queue as before with message test1. Hit send, and we receive this test flow receives the message. Now, if we go to Postman, if everything works, we issue a GET request to this with this URI specifying the two parameters, name and action, and this is gonna stop the flow. So this I issued the GET request. The payload response payload was empty, so because I didn't code anything. But let's look at the console. We can see from the log entries that actually the test flow has been stopped, as you can see here. Stopping service test flow stage 1. So if we send another message while the flow is stopped, the message should stay in the queue because it's not being picked up by the test flow. So let's send test2, send, and you see there's a number of pending message equals to 1. Let's send another message. Let's send test3 to the same queue. And we see that also this message is queued, and now there are 2 pending messages in the queue. What we're trying to do now is to restart the queue, and then we specify action start, but we could specify any action which is not different from stop because the start action has been assigned to the to the default branch of the choice router. So anyway, let's specify start. Again, we have empty response, and what we see is actually that the flow was started again, and including, of course, its JMS data source. You can see here, and after the start of the flow, the two pending messages have been received. And if we look, refresh the ActiveMQ console, there are no more pending messages. So we can see how we can dynamically and programmatically start, stop, or rather in this case, suspend the flow, and then start it again. In this case, because there is a queuing mechanism, because the data source is JMS, we're not losing any pending messages. Obviously, if I started a flow that is whose data source is an HTTP connector, then obviously it will this endpoint would not be available to consumers, to clients, while the flow is stopped. Just another thing before we close, if I specify the start action again, I get an error, and the cause of the error is the fact that the flow is already started, so I cannot, the start action is not consistent with the life cycle state of this flow. If I go and look at the exception, it says illegal state exception. The flow is on life cycle phase start, and it cannot fire the same phase twice. So I hope this has been useful to you, and this is an example of what can be done to control flow without using the Mule management console or other consoles which are not available in Mule Community Edition. Thanks, and see you at the next video. Thank you.